All right. Yeah, I'm really excited to be here today, representing Safe AI. My name is Cynthia Brosque. I'm the Chief of Staff at Safe AI, and I'm also a lecturer in construction robotics at Stanford University. Our goal at Safe AI is to accelerate the world's transition to autonomous mining and construction. We're focusing on some of the biggest heavy industry issues like safety, of course, labor, aging workforce, recruiting challenges, but also the pressures that both construction and mining are facing in terms of their productivity that has to increase while also reducing and being better in terms of their operating costs. And part of our business model is also focused on the accessibility of these systems. Of course, we know mining has a long trajectory when it comes to autonomous systems, but still only 1 to 2% of vehicles globally are autonomous. And a big barrier for that is the cost. It's not that the technology is not ready, it's more how can we bring it to a wider range of customers, even those in quarries and construction where they may not have the same capability to spend in autonomy compared to large mining companies. The way we are addressing this challenge is by doing a retrofit model. So we take heavy equipment from our customers, which are usually the site operators who hold the assets, and we transform them into more productive and autonomous heavy vehicles. We have worked with all the kind of the different OEM brands. We are agnostic to the OEM, and we also work with different kinds of vehicles from rigid articulated trucks from 25 tons to 250 tons, and also with dozers. We take, for our retrofits, we take off-the-shelf hardware. So that includes LiDARs, cameras, drive-by-wire compute unit that goes into the cab of the vehicle. And that's the way that we can control the vehicle autonomous with our proprietary software. All of our software has been developed in-house and specific for industry cases in construction and mining. So usually we focus on very repetitive use cases like load hold dump cycles, and of course integrating obstacle detection, avoidance, depending on the requirements of the site. In addition to the software that runs on the vehicle, we also have 2 additional pieces of software. One is called Zeno, which is a fleet management system. So think about that like your Uber dispatch within the site. So there's still a manager that needs to give the high-level decisions of what task is going to be needed today at the site. So those planning decisions happen at Zeno, and then you can also retrieve all of the performance indicators. And then the second smaller piece of software is a vehicle-to-vehicle telematic device for integration between the autonomous assets and the non-autonomous. So for example, the loader is not a use case that we have retrofitted. So the coordination between the loader and the operator that is sitting in the loader and an autonomous truck happens through flags. And I'll show you a little bit more what that looks like. We have also done a full autonomous and electrical retrofit. This was a collaboration with a company called Avia Engineering in Spain, where they took care of retrofitting the diesel motor with batteries, and we focused on the autonomy piece, and we wanted to show that basically it was a full retrofit for an existing vehicle. This is what Zeno looks like. Yeah, just a little bit of you have some capabilities for map management, taking a look at your fleet, engine hours, fuel, anything you would want to know about the autonomous asset, progress on the assignment being completed. And then this is a quick view of the flags system. This is one example for the loader installation. So you would get information about all the vehicles in the fleet, how low the percent of being loaded for the truck, and then once it's ready, the operator can just click kick and the vehicle will continue. This is a pretty simple user interface with train operators on site, and it takes just a couple of hours to get used to it. Our overall architecture, we start from the bottom up. So on the vehicle itself, we basically don't modify how the vehicle is operated manually. So that means at all times, even after the retrofit is completed, you can still drive the vehicle manually as you would normally do. We do install a drive-by-wire layer that communicates with the canvas of the vehicle. So that's our way to digitally control, brake, steering, etc. And that drive-by-wire controller talks to our autonomous kit computer that sits in the cab of the vehicle, which includes modules for perception, localization, behavior planning, mapping, and control. And that control ultimately gives the drive-by-wire the ultimate decision of what to do next. Of course, the autonomous kit is relying on all of the sensory data coming from the LiDAR cameras, GNSS, information from the outside world, so it can react in real time. We do use, we're agnostic to whatever network the site has, and we have worked with LTE, 5G, but also with systems like Radiant and really flexible infrastructure. And that connects to the fleet management system for giving out the assignments, equipment configuration, map maintenance, and that high-level decision-making, which goes onto the vehicle. Currently, we're operating in the US with CRH Ventures, actually quite close to where we are sitting today. We're operating in a quarry site in Georgia. This is a pilot for an aggregate quarry. Like, the operations are a bit tighter compared to mining, but the use case is still pretty similar, where we have load haul dump operations from the pit to the crusher. We're also working, this is the agnostic electric and autonomous solution that I was mentioning. This is a project that is currently in operation at a ferrovial site in Spain. They recently opened their innovation lab, and we're showcasing this technology there. And we saw this as a blueprint for how the industry can begin to transform. Of course, there's some offerings as well from the OEMs in terms of new vehicles, but this was also that alternative on the retrofit side and trying to make it more economical. We've also done earth moving in mining. This is an example from a gold mine in 2024, where we retrofitted two mixed fleet vehicle, and that's a key part because we're agnostic. We can work with several OEM brands in the same site. And here we moved more than 20,000 tons of topsoil production material movement. And we had mixed fleet interactions with manual vehicles as well that could enter into the area, and working together in coordination with the loader as well. I just want to show, to wrap up, a couple of videos. This is from a site in Japan. So what we're seeing here, there's no operator in the cab. That's kind of the ultimate goal for us in terms of full automation. There is someone operating the loader, and they are communicating via flags. So as the vehicle continues to dump the piles, particularly in this project, it was important. The customer wanted to see the collaboration between the dumper and the dozer to then flatten the piles. So I'm gonna skip to the next video. So here we see a fully retrofitted as well autonomous dozer, no human in the cab, and basically just flattening the surface to the desired height. So of course, this can be just one use case for the dozer, but there could be others both in construction or in mining to just push material or flatten it, as in this case. And finally, we also participated in the Japan Ministry of Land, Infrastructure, Transport and Tourism demonstration. So last year, a lot of autonomy companies were invited to showcase their technologies and show specific features. And that was a way for the government to also understand where the technology is going and how they can help evaluate and from a normative perspective as well, how these systems are going to look like in the future. So we did a bunch of demonstrations also with this two vehicle coordination between the hauler and the dozer. I think that's it. We'll take some questions at the end. Thank you so much for your time. Sorry I couldn't be there in person, but very nice to see you all. Thank you.